Mary Kay Amistadi from University of Arizona. She's a lab manager for a lab for environmental contaminants. And she's a very experienced chemist. Unfortunately, her scheduling conflict would not allow her to come and do the presentation. So I will do the presentation for her. Please do not shoot the messenger. If I can load it. There we go. So the Mary Kay's lab, where she's working on that, was established in 2008, and it was a collaboration of 5 colleges that apparently exist on the University of Arizona campus. And goal is to provide analytical support to all of these researchers from these 5 different colleges for mass spectrometry, and that includes ICP-MS and LCMS, I believe, yeah. So the lab is equipped with Agilent 2 systems, 7700 and 8900 triple quad. So the environment of this lab, when we started to work with Mary Kay, so when she started to talk to me about what kind of samples you run, and she would answer, I said, run everything. So here is the snapshot of the logbook. So starting from environmental samples, soil extracts, waters, then you go into biological, then you go to plants like woods. They're looking like for taking the wood cores and they digest them to see what's going on with years, and then insects and the clinical, I guess, everything under the sun that brought into her lab that she has to deal with. So here is the examples of the nice-looking samples that she has to handle on ICP-MS. This is the soil extracts, and you see, what you see here is the solid particulate at the bottom, right? They settle, but that's what you see. So here is the example of the wood digest, and this is the clinical samples. You see serum on the left and whole blood on the right. So everywhere, the reason she put the slide together is to show what lab has to deal with, what comes in for ICP-MS. Challenges. So as you see from this logbook, the nature of the samples that this lab deals with changes daily. So if some of you guys, you commercial lab, like Dion showed his samples and Melissa, but they're tough. That's why we got these speakers to present it to you, but at least they're somewhat consistent on the daily basis, right? Here, today she gets some, insect and scorpions, and tomorrow she gets drinking waters, and the day after tomorrow they get blood and urine. So, but the lab is loaded. You don't have time to develop the method and do everything in infiltrate. So sample throughput still runs as a commercial operation. And this was the challenge. So in order to deal with that, with the current nebulizer or sample introduction, as I say, that comes with the instrument, she has to filtrate samples or centrifuge, and this was done, but it adds time and it adds cost. So quite often, as she mentioned to me, so she would set it up on the autosampler and a few hundred samples, hoping it's going to be done. She comes in the morning, and after 10 samples, everything stops, nebulizer is blocked, even after filtering and doing all of these things. That's what she has to solve. So we introduced the OptMist ION Nebulizer at this conference in 2020. And then she came to our booth and started to talk to us. So long story short, we said, okay, try this nebulizer. This is exactly what it's designed for. It was designed for ICP-MS. We applied the patent at that time, and we're getting it out to people. So the nebulizer has non-concentric design. You have sample and gas separated. So similar to actually any of our nebulizers that you had a presentation with. So they're different than concentric nebulizers that have sample and gas kind of concentrically positioned, so everything is restricted, and that's why you get problems. Plus, the size of the sample capillary on the concentric nebulizers for ICP-MS specifically are not just small, they are tiny. 140 microns. What is 140 microns? It's almost the size of the hair, right? You breathe in this nebulizer, it's going to stop working. So here, we came up with a design that allows 0.7 to 0.8 millimeters, which is similar to OptiMist Vortex and a little bit less than OptiMist Ultimate. There is a trick. I mean, there is a challenge. Why, there is a high solace nebulizer with opening. Why everybody don't put it on mass spec? The reason is because it's difficult to make, with a large opening, the nebulizer to work at the low flow sample uptake rates that modern ICP-MS instruments are functioning at. So here's the setup on both Agilent's machines. So we have to provide the adapter, and you see the concept of this nebulizer is similar to what Mike showed from the OptiMist Vortex. It doesn't shoot straight. It has the impact plate, and then the gas goes and hits, and the aerosol is diverted slightly under the angle. So that's why we've designed a end cap that fits Agilent's cut spray chamber, while the different other, if you have mass specs from Thermo or PerkinElmer, they have cyclonic, so you don't need this adapter. It will go straight to cyclonic, just have to be turned the same way as the Vortex. Similar concept. So, and this is after, so we did this work with her on with Mary Kay on clinical samples, and then she put the nebulizer on one system, and then she had a snapshot of 9 months running, 17,000 samples, no blockage, no maintenance. She didn't do it. Well, did you have to clean it? I said, no. Why? Well, you calibrated, it's running. So that's what she got. Again, I'm just a messenger. Just that should be. So here is some stability data. That's 12 hours on rhodium internal standard, just to give you an idea about the performance. And of course, the question is, well, yeah, the nebulizer is capable of handling the particles or not cloud. What about the sensitivity, right? Because everybody knows spec wants the sensitivity. And there are some other nebulizers that will provide you the robustness, but you trade off the sensitivity. So here is, there is a bunch of data, but here is the example of, typically, it is in par with concentric nebulizer. So within, let's say, within 10, 15%. But what we found interesting, that's why it's in this presentation, she was looking for mercury on 8900 system on triple quad. And surprisingly, they saw the signal that's higher on OptMist ION than on the concentric nebulizer they've been using. So this is the net intensity comparison. So net intensity means, so when we look at this, ask, well, what is the blank value? And then she took the intensity at 10 ppt, subtracted the blank, and this is what you got. So I said, well, let's take a look at the calibration. So here is the comparison of the calibration, and this is average over a few days. It's not just one run, because when I saw this data, I had a hard time to believe in it, right? So I know it's going to be in par, but it's going to be better. So that's pretty interesting. So yeah, you can see this slope, right? This is the coefficient of the curve, linear regression. So you have 17 here, and you get what, 32 or 34, something like that. And that was average within a few days. So it is real. What is the explanation for that? We have to come up with something, but I think maybe if the nebulizer is giving maybe a little bit less solvent load, it lowers the temperature of the plasma. Now, mercury, surprisingly to me, when I started looking at the ionization potential, has very high, not just high, very high ionization potential in par with phos and sulfur. Higher than arsenic and selenium. It's around 10 point something electron volts. So it is known effect that if the temperature of the plasma will have dramatic effect on the elements with high ionization potential. So my guess is if we have a bit of a less solvent load, the temperature of the plasma is higher and the mercury goes up as compared to maybe a bit more giving regular concentric nebulizer giving a bit more solvent load. But again, this is just my guess that I'm sharing with you. And conclusions. So the employing of the nebulizer allowed the lab to eliminate completely any filtration, any centrifugation. There was minimum, well, almost no maintenance, but let's say minimum maintenance. And that allowed to increase the efficiency and sample throughput. So again, when the batches of sample that would be set up, previously it would have to be around 2, 3, many times, because she would come in the morning and then the nebulizer, the system would stop because of the cloggages. Here, everything ran fine. Of course, there was regular issues associated with mass spec in general, cleaning the cones and all other stuff, but at least that portion seems to be being taken care of. And so that seems that the nebulizer offers the possible practical solutions to some of the labs that run these difficult samples, so it can be run trouble-free or reduce the cost. Because one of my customers, environmentalists, he told me they in order to run it through their default nebulizer, they have to filter each sample with a syringe filter, and now the cost of these filters went dramatically up. It's almost $2 per one. So you multiply by amount of samples, and this is the cost of your lab. Anyway, that's it. And please, any questions?
So what is the typical sample uptake rate of this nebulizer?
Yeah, that's a good question. The nebulizer we've tested it from about 0.1 to 0.8 mils per minute. So on these experiments, on the Agilent, the default rate is 0.4. Yeah, somewhere between, we put internal standard, between 0.3 to 0.4. But it works well within this range. That's why it was specifically designed for ICP-MS, which has a low uptake rate. We tried it even go to lower than that, to 50. It still does pretty decent job. Yes, please.
The increased sensitivity observed for the OptiMist nebulizer, does it happen for other elements?
No, just for mercury. No, just for mercury. Yeah, that's what's interesting. The other elements were in par, maybe a little bit less, a few percent less, let's say 10, 15% less. But the detection limits, when you look at the curve, even with slightly less intensity for other elements, were the same or better. Anyway, it was comparable. There was no loss. We didn't see the loss on the detection limit side, and that's basically make it They're very unique and different. Because there are, there are a number of high solids capable nebulizers. You put them on mass spec, you start to run them at 0.4 mil per minute, they started to pulsate, they started to starve for the sample, and then you lose the sensitivity by a factor of 2 or 3. And your RSD is going to be 3-5%, right? So here, the performance is in par with regular concentric nebulizers. All right, well, thank you. Thank you very much for coming. There is still plenty of food. Please come and enjoy it. There is plenty of time.